Even if I wanted to, and I can't change. Even if I tried, even if I wanted to. My love, my love, my love, she keeps me warm. She keeps me warm.
Hello and welcome back. So as you can see, I'm in a different location this time. I'm actually in my apartment in San Francisco, and behind me is a wonderful abstract piece of art of the sun setting on a city. So that's something that you can gander at while also learning about math. All right, so even though I've changed positions, I am still the same person. And so what we're going to find is that even though the triangles might change positions, the triangles can still be congruent. So the first objective is to prove triangles are congruent by transformations. And the second objective is to prove triangles are congruent by using the definition of congruence. All right, here we go. So congruent figures perfectly overlap each other if transformed by an isometry. So that's what you're going to put in the really big starred thing on a piece of paper. So if you can transform them using an isometry, then those figures are congruent. So as a reminder, an isometry is like a rigid transformation, and there are three different types of rigid transformations: reflections, rotations, and translations. So if you can reflect it, rotate it, and or translate a shape, then you know that the figures are congruent. So if you can prove that a rigid transformation can be done, then the triangles are congruent. So since I can slide that one over, these triangles are congruent. Now let's take a look at two more examples. So let's take a look at the one on the left. Using transformations, prove if these triangles are congruent. So is triangle BXG congruent to triangle B prime X prime G prime? Yes, they are congruent because rotating BXG 180 degrees about the origin will result in triangle B prime X prime G prime, which is, since rotation is a rigid transformation, all we're doing is changing the location or the position of the triangle. The triangles are still congruent. Now let's take a look at this one. Is ABC congruent to triangle DEF? While it is true that a transformation is happening, it was slid like down and to the right, but it also got bigger. So the size changed. So that this would be no. ABC is not congruent to triangle DEF because no rigid transformation can move triangle ABC to perfectly fit triangle DEF. They are not the same size. So they need to be, in order to be congruent, they need to be the same size. Okay, now we're gonna, so that was 5.3a, looking at it through transformations. Now we're going to look at how triangles can be congruent through the definition of congruence. So congruent polygons have the same size and the same shape. So polygons is any shape. For now, that's what a polygon is. It's just basically any shape. It must have the same size and same shape. Corresponding parts are the angles and sides that are in the same position. So like when we have like the two triangles over each other, the two sides that were like on top of each other are corresponding parts. The two angles that were on top of each other are corresponding parts, and so on and so forth. So all the sides that are on top of each other and all the angles that are on top of each other are corresponding parts. So in a triangle, there are 6 corresponding parts. 3 angles that are corresponding and 3 sides that are corresponding. So that's like, 3 angles and 3 sides that are corresponding. And then congruent triangles. Triangles that have congruent corresponding parts. So this is the definition of congruent triangles. It's triangles that have congruent corresponding parts. Congruent corresponding parts. All right. So properties of congruent triangles. So if we know that triangle ABC is congruent to triangle DEF, so ABC is congruent to DEF, we can then say that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. So those are the corresponding angles. Also, we can tell that the corresponding sides are congruent. So AB is congruent to DE, or the order that you say them in doesn't really matter. It helps that they are said in the order that like he did both of them with the corresponding angles. So AB and DE are congruent. BC and EF are congruent. And then AC and EF are congruent. Also, it's a helpful hint, but something that is like need to know is that when you write a congruent statement, such as triangle ABC is congruent to triangle DEF, the order of the vertices indicate the corresponding parts that are congruent. So it's the order of the triangle really, really matters. By just looking at triangle ABC is congruent to triangle DEF, I could tell you all of this information. I can tell you that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. Because since the first letter indicates like those two angles are corresponding and thus congruent. Okay, so the order does matter. All right, so let's take a look here. Given triangle XYZ is congruent to triangle NPQ, identify the congruent parts. All right, so angle Z would be congruent to angle Q. Q. Angle P would be congruent to angle Y. We can also tell because P and Y are the second letters in the congruent statement, so that's another way of telling it. Side NQ would be congruent to side XZ. NQ is congruent to XZ. I can also tell that by this congruent statement. N and Q are the first and third letters, so X and Z would be the ones that are congruent because it's the first and the third. YZ would be congruent to PQ. PQ. Angle X has 3 tick marks. It's going to be congruent to angle N, which also has 3 tick marks. They're also the first letters of their triangles in the congruent statement. So angle X is congruent to angle N. And then PN is congruent to YX. Okay? So now, example, proving triangles congruent. So you can prove triangles congruent by using the definition of congruence, saying that the corresponding parts of 2 different triangles are congruent. So here it's given that angle D and angle B are right angles. Angle DCE and angle BCA are congruent. Point C is a midpoint of DB. ED is congruent to AB. And EC is congruent to AC. If this looks pretty familiar, this is the same exact proof from our pre-assessment. So prove that triangle EDC is congruent to triangle ABC. So basically, we need to prove that angle E is congruent to angle A, angle D is congruent to angle B, angle C is congruent to angle C, segment ED is congruent to segment AB, segment DC is congruent to segment BC, and segment EC is congruent to segment AC. Once we've done all 6 of those corresponding parts, saying that they're all congruent, then we can say that the triangles are congruent. Here we go. So it was given to us that angle D and angle B are right angles, and we can say that they're congruent because of the right angles congruence theorem, saying that all right angles are congruent. Angle DCE is congruent to angle BCE. That was given. And so angle E is congruent to angle A. So remembering back from 5.2b, when we have two angles that are congruent and two different triangles, we can then say that the third angles are congruent. So this would be third angles theorem. C is the midpoint of DB. So therefore we can say that DC is congruent to BC. And that would be definition of midpoint. And then we were given and so we can draw tick marks, oops, and boom, 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 and then arc marks for E and A. And now we have all 6 corresponding pairs that are congruent. The angles, boom, 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 and the sides, 1, 2, and 3. So therefore, we can say that the triangle EDC is congruent to triangle ABC. That's definition of congruent triangles. All right, that's about it. You have an online quiz, and then your application is going to be a little bit different. It's going to briefly touch on these, but it's going to mostly be previewing the next unit, the next section, because the next section is like the crux of this whole unit. All right, thank you guys. Have a good one. Bye-bye.